The final images from Titan, Saturn's largest moon. Far away from Earth, Saturn is orbited by the most complex and mysterious satellite in the solar system. But what makes Titan such a unique celestial body in our solar system, and why does it attract so much attention? The number of incredible features on this satellite deserves its own documentary film. Our video today will touch upon Titan's unique atmosphere, liquid present at the surface, a landscape very similar to Earth, an ocean of warm water, breathtaking rains, and finally, a form of life that not everyone can imagine. These mysteries compelled us to research the available information about Titan and try to fit it all into one video. This satellite, resembling the young cold Earth from the past from a scientific point of view, invites you to take a deep dive into its mysterious nature. Among the 63 known moons of Saturn, Titan immediately stands out as the largest one, and it truly is gigantic. Its diameter is 3,200 miles, larger than Mercury and only slightly smaller than Mars, although its size allows amateur astronomers to study Titan even without a professional-grade telescope. Until recently, it remained a major mystery. This moon was discovered in 1655 by astronomer Christian Huygens, who noticed an object moving alongside Saturn. It had been seen before, but it was assumed to be a star. The first probe to visit it was the Pioneer 11, followed by Voyager 1 and Voyager 2. However, the initial images could tell little about the satellite, but they already showed something unusual. The haze that obscured Titan from the eyes of scientists turned out to be layered. Its top layer mainly consisted of hydrogen and nitrogen. Further attempts to study Titan using the Hubble telescope were unsuccessful. Research was revived by the renowned astrophysicist and advocate for planetary science, Carl Sagan, who speculated that if the temperature on Titan's surface is negative to 190 degrees Fahrenheit, then methane, becoming liquid at this temperature, could be spread across the entire surface, meaning that Titan is a place where one could witness an ocean of methane. Anyone who uses a gas stove is familiar with methane as the gas we ignite for cooking. Now, imagine a place where this gas becomes liquid, where it falls from the sky in the form of rain, forming methane rivers, and where these rivers flow into gigantic methane seas. In 1997, the Cassini probe was sent to Saturn with a mission to study the planet itself as well as its satellites. Although Titan was not the main focus of this journey, the Cassini probe included a special spacecraft, Huygens, which was launched toward Titan in 2004. Almost half of the data recorded during its descent was lost, but we were given the opportunity to immerse ourselves in the journey to the surface of Titan. The descent took about 2.5 hours. The atmosphere on Titan turned out to be so dense that Huygens floated down with a parachute, deviating from its course, and spun so fast that many images taken during the process were ruined. The descent to the surface also revealed the scale of the atmosphere. It turned out to reach over 300 miles above the surface, which is a record height for the entire solar system. Titan's atmosphere is clearly divided into several layers, composed of different substances, and very diverse in terms of temperature. While the temperature on the surface is negative to 190 degrees Fahrenheit, at a height of 200 miles, it is much warmer, only negative 130 degrees Fahrenheit. At the top, Titan's sky turns blue as it is filled primarily with nitrogen and hydrogen, but at a height of about 250 miles. The aforementioned orange haze begins to form, which continues down to 60 miles, only dissipating as you approach the surface. At a height of about 30 miles, the surface of the satellite becomes visible. For many, it will look quite familiar, as the landscape includes mountains and rivers. During the landing, Huygens discovered that the orange haze layer is fairly evenly opaque throughout. Here, sunlight never really reaches the surface. This is what a sunny day on Titan looks like at noon. Although the surface has texture, it's still relatively flat, but the highest parts of the land only rise as high as 0.6 miles. Take a look at this first image taken by Huygens upon landing. It's likely that the spacecraft landed in a dried-up bed of a methane river, leaving behind some smooth ice rocks that look like pebbles. They had been preserved since the time the river was still full of liquid methane. That was pretty strange. There were no traces of liquid. Where did the supposed methane rivers go? It was quite strange. There were no traces of liquid. Where did the presumed methane rivers disappear to? After processing images from the landing, several of them were merged into this collage. Here you can see an image of a river system with many branches, not too dissimilar from some places on Earth. This prompted several theories about where the liquid could have gone. The first theory sounds quite terrestrial. As Titan's climate cycle changes, these rivers fill with methane rain and then dry up again. The second theory, proposed by scientists, suggests that these methane rivers extracted liquid methane from underground sources that ceased functioning for some reason. Let's start with this photo of the atmosphere, taken by Cassini to begin unraveling the reasons for such opacity in Titan's atmosphere. The thing is, it consists of several layers. The first layer is essentially the largest factory producing complex organic compounds in the solar system. Right there, at an altitude of over 300 miles, methane, nitrogen, and hydrogen are exposed to sunlight and transformed into more complex elements, which then begin to descend to the surface, creating a new layer. The second layer is located between 200 and 250 miles from the surface and consists of tholin haze. An example of tholins on Earth is soot produced as a result of the combustion process. The third layer begins at approximately 200 miles altitude and consists of inorgassed ethane. Here, scientists have noted a unique greenhouse effect. On Earth, gases in the atmosphere trap heat and warm our surface, leading to the greenhouse effect. On Titan, tholin haze and ethane create the opposite effect, essentially forming a shield that sustains both the warmth from the sun at 250 miles altitude and the cold temperatures of -190 degrees Fahrenheit at the surface. At an altitude of about 60 miles on Titan, there are even clouds, although very few. And although the climate on Titan changes very quickly compared to Earth, a real tropical methane storm was recently recorded in the equatorial region of this moon. Thanks to its unusual shape, this storm earned the nickname Arrow and covered an area of 200,000 square miles. The methane rain that fell from the sky during the storm looked very unusual compared to the rains we experience on Earth. Imagine raindrops the size of pears, slowly descending so that you could easily dodge them. Huygens and Cassini were able to confirm the composition of the atmosphere. Like Earth, Titan's atmosphere is mainly nitrogen, but it also contains 3.5% methane. But that wasn't the most interesting part. On Earth and on many other planets, chemical processes occur at the surface. On Titan, however, its chemical reactor is located at an altitude of 300 miles, leading to huge amounts of organic compounds descending to the surface. Over 4.5 billion years ago, Earth was exactly the same, the only difference being that Earth was warmer due to its proximity to the sun then and now. And the organic substances that fell from the sky did not land on methane dust on the surface and liquid methane, but fell into water-filled oceans. After studying the composition of the atmosphere and its layers, scientists encountered another puzzle. It is calculated that the methane currently in the atmosphere should have disappeared within 10 million years of the formation of this atmosphere, yet this did not happen. Something continues to fill the atmosphere with methane, maintaining its level for over 4.5 billion years. Some scientists speculate that during Titan's formation, there was so much methane that the reserves have not been depleted to this day. Others have speculated that methane is produced by some chemical processes occurring on the surface, and even that there are organisms that produce methane as part of their life cycle. This was the first hint of potential, albeit primitive, life on Titan. The second puzzle for scientists was the amount of hydrogen in the atmosphere. It should be 2.5 times less. It was not clear where so much hydrogen came from until it was established that hydrogen in Titan's atmosphere is in the form of water molecules rather than in a free form, which somewhat mitigates the mystery. Some scientists speculate that water molecules in Titan's atmosphere formed as a result of collisions of orbital ice squeezed out of Titan's icy core. There is another theory that water molecules formed when nitrogen molecules contacted halogens found on Titan's surface. In both cases, water molecules in Titan's atmosphere are produced by photochemical reactions similar to those that occur on Earth. Studying Titan as part of the Cassini-Huygens mission brought us several remarkable discoveries and created even more mysteries. But scientists are not stopping there, and future missions to Titan, such as the Titan Dragon mission and potential missions using unmanned spacecraft, will continue to explore this amazing world, uncovering more secrets of this enigmatic moon of Saturn. Giant cryovolcanoes have been discovered on Titan, erupting liquid water instead of molten lava, like on Earth. These volcanoes create flows of water, forming rivers and lakes, which is a unique phenomenon in our solar system. Additionally, vast areas with enormous crystalline formations, resembling icy mountains or plateaus, are also found on Titan. These structures may result from processes similar to geological ones occurring on Earth. But due to differences in composition and conditions, they take on a completely different appearance and form. Studies have also shown the possibility of vast underground oceans on Titan, confined beneath icy crusts. These oceans may be crucial for understanding potential life on this moon, as well as for understanding the evolution and formation of planets and moons in general. Furthermore, observations of the methane cycle on Titan indicate that it may play a similar role to the water cycle on Earth, but in an alternative form. This cycle involves evaporation, condensation, precipitation, and runoff, sustaining the dynamics of the moon's atmosphere and surface. These amazing facts about Titan underscore its importance as an object for scientific research and prompt us to contemplate what other mysteries may be hidden in this enigmatic world. Additionally, Titan attracts the attention of scientists with its peculiar climatic conditions. For example, meteorological phenomena observed on its surface are rare in other bodies of the solar system. Recently, a massive methane storm around the equator was recorded, sparking interest in the mechanisms underlying such phenomena. Moreover, studying Titan may help us better understand the origin of life in the universe. Its unique mix of organic compounds, including methane, ethane, and other hydrocarbons, as well as the potential existence of liquid water, make it one of the most promising places in the solar system to study primitive life and its potential forms. And finally, Titan remains one of the most mysterious and astonishing places in our solar system, where each new discovery opens the door to new questions and hypotheses. Perhaps in the future, bold space missions and further research will help uncover some of the deepest secrets of this remarkable world. In conclusion, Titan continues to remain one of the most astonishing objects in our solar system, sparking interest and inspiring our boldest scientific fantasies. Its unique characteristics, mysterious atmosphere, and potential for studying primitive life make it a focal point for further space exploration. Ahead of us lie many more discoveries and journeys into this fantastic world, where each step brings us closer to understanding our cosmic environment and its potential for life.